to the panel. And I'm going to turn it over to Peter here from HP. And I think the best expeditious and casual way to keep moving, introduce yourself when it's time for you to talk. However, very quickly though, this is Mitch from Deloitte, Linda from Texmark. This is the customer here. This is the most important one here.
It's a partnership.
Yeah, Anna from Intel, and Daniel Newman, the author and consultant. Okay, so Peter from HP, take it over.
Hi, Peter Moser. I'm the Chief Technologist for Hewlett Packard Enterprise, and I've been engaged with this project, this transformation for quite a while.
Okay, so I'm Linda Salinas. I'm the VP of Operations at Texmark Chemicals, and it has been an exciting journey with all of our partners here on the team.
And I'm Mitch Hall with Deloitte, and I've been working with the team on the turnkey IoT offering, our predictive monitoring and asset monitoring and maintenance. And we've worked with the team since last summer.
Yeah.
Well, I'm Anna Scott with Intel. We're supporting the video analytics solution.
Daniel Newman, Future and Research. I work closely with the Intel IoT team on research analysis projects, and I'm going to kind of make you guys answer some difficult questions when you're done with the pre-planned presentation. Yeah, get the rest of you guys, hopefully. I know you guys know how to ask tough questions, so let's make this a great conversation.
Yeah, so I'll get started. Tell you a little bit about the Refinery of the Future, and just kind of leading off of Dr. Tom's intro. And first of all, congratulations to the award recipients. What a great honor to be recognized among your peers and here among this Refinery of the Future panel. Dr. Tom is right. He's always right, by the way. But Texmark is at the edge, and I've got to tell you, my favorite thing at the edge are 50 people on our team. They are my favorite things, and they are the reason why we're here today, is to empower them, to enable them with the IoT technology, to enable them to make these right decisions for our business. Happy employees, our productive employees, our safe employees. And at Texmark, if you've ever visited the Refinery of the Future, you'll know we like to have fun, and we love each other, and we do love technology, and we love making money, and we love working with other partners. So that's kind of at the core of why we do what we do. Texmark is a family-owned company. We primarily produce through distillation and reaction. We're the #1 producer of dicyclopentadiene. The acronym for that is DCPD. All together now, DCPD. We also produce various alcohols and aromatic solvents, and we do some contract manufacturing. So one of the ways that I see IoT, aside from enabling and empowering our employees to do great things, to work more efficiently and be more productive and be safer, is this value add of IoT in our contract manufacturing arm of our business. When we talk about being able to employ IoT and having this data being the next commodity, or the next goal. We talk to our contract manufacturing clients, and they come to us and they say, well, you know, we'd like to free up our equipment in the plant. Can you process this chemical for us? So they'll bring us their raw materials, they'll bring us their recipe or their process, and we'll run it through our distillation tower, through our reactor, and make that product for them on their behalf to ship to their customers. Wouldn't it be great to be able to add IoT on top of that project, either censor that process for them, provide them a dashboard so that they can see their data, so as we're producing this real time, they can be capturing that data and tweaking the process and work together with us to even improve the product that they were making at their own facility. So that part of it has been really exciting for Texmark and IoT, and I know that our panelists here are going to go through some of the details on the use cases. So who's next?
Thank you. So just kind of a recap. So those that aren't familiar with Refinery of the Future, it's been a journey for about almost 2 years from inception, but the actual use cases and the like started about 18 months ago. And we've been telling the story about how the journey began, right? A digital transformation of not only the business, but also their processes through technology. Just to give you a sense of some of the changes that have occurred in the status, because we get asked that quite a bit. The first thing that Texmark needed to do was focus on mechanical integrity. Because one of the things that they experienced is that if you don't have a really good mechanical integrity plan, the insurance companies will raise your premiums. They'll double them in the deductible. So it can be kind of expensive. So that was a reactionary move, and they did a nice job by doing a 3D scan of the entire plant. The plant's 50 years old. You can imagine the as-built plans don't match what the plant looks like today. So it's very important to have an understanding of what does the plant look like today. That becomes more of a foundation for the use cases, because if you don't know where the assets are in the plant, you don't have IDs for them, it's kind of hard to work on them, right? And to maintain your operation. So that was kind of at the core. That's complete. Now they're inputting all the PNIDs for all the assets into Palladio, and that's going on right now. The second thing we need to do is we need to have connectivity. Because if you think about it, if you're going to start adding sensory to existing pumps and motors, to give you some context, the duty life of these assets are 5 to 40 years. So they're not going to be replacing them anytime soon. So if you want to get some sort of insights from these assets, you're going to have to add the technology to those assets, right? And so there's two ways you can do it. You can connect it with Ethernet at about $8,000 a run. Or you can do it wirelessly at about $700 to $800 a pop. So you kind of look at the economics. So wireless was kind of winning out. So pervasive Wi-Fi across the plant facility, and that's complete. Then you had to look at your infrastructure. Can your current infrastructure and system support the new use cases? In their case, no. In probably a lot of customers' cases, no. Because typically in the petrochemical space, there's not a lot of change, right? Those environments stay very static for long periods of time until you have a turnaround, which is usually about every 4 to 5 years. Yeah. Yes. So your cycle for change doesn't come along very often. And so one of the things you can't do is totally disrupt your operations where you can lose money and do introduce risk. So the next thing to do is get an infrastructure, a secured infrastructure in place that can support the use cases. One that could support all the use cases. What we didn't want to have were point solutions. And so that's when we brought in the micro data center with RoTF 4000, and that became the foundation coupled with the wireless infrastructure to start building the use cases. Once we got that in place, then Texmark started prioritizing the additional use cases that they wanted to layer onto this. One of the things I did mention earlier, they were also evaluating an update to the distributed control system, so that process is still underway, but they narrowed it down to 2 candidates. So once we do that, then we started thinking, okay, what pumps do we want to add telemetry to? And since Linda's VP of operations, she said, let's just take our 2 most mission critical pumps and put telemetry on those, because for her, she said, we've got a problematic pump that we really need to get our arms around. We've got another that could add value to those trade customers, right? Because that boiler kind of gets involved in just about all their processes. So let's add telemetry to those. So now we'll start focusing on monitoring. The good news is, to let us help here, we're collecting data we have for several weeks, and we're starting to not only monitor those pumps, but start building the models, because we're using machine learning to start beginning to predict the analytics piece. And Mitch is going to talk about that in detail. So that's complete, and that's in progress on the model building. Then now we're starting our next 2 use cases, the connected worker. Because once you create the insights, how are you going to consume them? I can't say really, like you do have the personas already built in. Right. Okay, so that part's done too, and Mitch will talk about that as well. But when you start creating the insights, you have to disseminate it to somebody to act on. And that's where we get into the persona dashboard. Because I think everybody understands that each role in the company is not the same. You know, Millwright doesn't need the same data as a CFO or the operations manager. So it's very important to give the right information to the right person at the right time in proper context. And that's where the persona dashboards come into play. And so that's where we're at. Then additionally, we're working on video analytics with Intel, and Anna's going to tell you about that, because video analytics and video as a sensor also is a huge leverage point. When you start looking at cost, but when you start looking at the return that you get from the investment is substantial. And Anna will elaborate more about that. So we've made great progress. Our plans are to finish up these use cases, have all these pilots in place and evaluated. Then Texmark will make the decision on when to roll those out at scale.
Probably let Anna jump in, because you kind of just opened the door for her to talk a little bit about video analytics.
Perfect.
So with video analytics, we had a lot of choices in terms of which use cases to go with Texmark. I think altogether they brainstormed at least 14 different use cases because the power of being able to use video and then couple that with analytics so that you cannot have, well, let me see if I can give a better example. So normally we're all used to taking video, right, for security purposes and being able to look at that, but then you need the human that's sitting there and ingesting that data and saying something's happened that we need to take some community response on, right? Video analytics, as you guys are all aware, now that you can do object recognition, facial recognition, and even more sophisticated things, it opens up a whole world of how you can start doing monitoring within facilities. So we're actually going to start with a use case that is looking at what is happening on their railway tracks. So they have a rail tracks that move through the south side of their facility that they use for loading, and they also have traffic from other complex or other businesses in the area will use those tracks as well. But they have 4 loading dock stations. And those tracks are pretty much open to an area that is not particularly well controlled because it's along a bayou. So there's a potential for both unauthorized humans and unauthorized animals to kind of come through and enter the plant through the tracks or to be on the tracks. That always poses like a level of risk, right? And right now, it's not a big enough risk to really justify having somebody watch that on a 24/7 basis. What we get to do with video analytics is say, now you don't have to have a human watching it all the time. What you can do is set up the cameras and then use object detection, which is just a version of artificial intelligence, to say, hey, there's something that's happening on the tracks, and wire that sort of detection up to an alarming function that would then let the operators know that they need to go check it out, or that something's happening, and then they can make the determination as to whether or not they need to take action. So that's a great use case because it allows us to apply this technology in a way that's going to augment the current functions and needs of the plant, right? So this isn't something that's in competition with the operators. It's something that's going to make their jobs easier and more successful, and have the added value or the value of essentially reducing the risk of the whole facility by applying the video analytics. The thing to go back and tie into what Peter was saying around the structure is, obviously, to do this, we need the wireless network, and we need the processors on site that are of high enough power that we can actually do the streaming analytics. So being able to transmit that through the wireless network, although we may end up doing a combination of wireless and wired, because video workloads can be pretty high. So we need to have the detailed discussions around how much resolution and what kind of frame rates we really need to be able to deliver to satisfactorily meet the requirements of the use case. So maybe those will work over wireless. Maybe we need to do a wired connection into the gateway. But then from the gateway, we'll essentially go back to the servers that are in the micro data center and use the micro data center to do the processing. And that couldn't happen without having the infrastructure set up to be able to do that. There's a strong reason to keep all of that stuff on site, because if we're really going to ask for immediate action based on what they're seeing, we need to control the latencies, and then there's just some strong reasons why keeping that data on site is highly appealing. So, and we can talk about that a little bit if there's questions. But
let's let Mitch as the SI tie this all together.
Sure.
And then we'll definitely have some questions for you.
Great. Thanks. Yeah, so the use case that we worked on was the asset monitoring and predictive maintenance, as Peter described. We looked at the obviously lots of assets in the Texmark facility, but the 2 highest value assets that they wanted to do some predictive monitoring and maintenance on were the boiler feed water pump and the vacuum pressure pump. And so we had a pre-integrated offering working with some of our ecosystem partners. First of all, with HP Enterprise and with PTC and National Instruments, we'd had a pre-integrated offering called Turnkey IoT that we had some development and some analytics and pre-integrated works that we could develop a use case and deliver it within a 9 to 12 week period. So actually this past year at Discover, when we launched that, we looked and had an opportunity to connect with the Texmark folks and the HPE folks and said, hey, we think that we might be able to apply that in our facility, what we're trying to do around our journey to digitally enable our plant. So we actually looked at the fact that it was a pump, we also looked at other companies that had more expertise in pumps. So we included Flowserve. Flowserve has been in the pump business for many years. They had a lot of experience on doing predictive monitoring and determining when there might be an outage in pump situations. We also worked with a firm called OSI Soft with their Pi Historian, which is, you may or may not be aware, the historian is used in almost all the major petrochemical plants in the industry. So looking at them as a key partner to collect the tags and look for anomalies in the data that comes in. And then it's the data is then implemented into the ThingWorks platform that PTC has. And so while we could build a predictive model with some machine learning, we actually found that there's a company called Spark Cognition out of Austin that we both pulled in too, because they already had a lot of machine learning for pumps already developed. So we pulled them as a key partner. And then Allied Reliability, who had the expertise in the plant side of actually instrumenting and putting the sensors on the pumps and getting those connected. So we worked together as an ecosystem together, where Deloitte was doing the system integration, but also the program management for the whole overall project. And so we started, we kind of remember, because as you may remember about a year ago, we had that major outage situation with Hurricane Harvey. So we started right after that, because we were going to start right around that time frame. And then we were able to kind of work with our partners to get those systems implemented using the wireless network that Peter discussed, and implemented on the edgeline servers in the plant, and putting the VMs for each one of those applications, integrating those together. And as Peter indicated, it's not just about the technology, it's about what that does and impacts for the people. So we actually looked at the journey maps of, what's the day in the life for a millwright today, and what's going to be the impact and improve the way that they operate as a result of this. So we did interviews with key folks in the plant, the millwright, the plant operator, and the plant manager, and said, how is this going to make that more effective for them? So we had sort of the before, the day in the life of before and after, and then we developed the software user interface using the PTC ThingWorks platform. And so, and then working with each one of our partners, we developed a training kit and training manuals that, as they begin to use, we have a reference there, but we're still engaged, because as we're collecting data now, as Peter mentioned, we want to make sure that the predictive models are fully populated. So that's kind of a brief overview of what Deloitte's role has been. And we're taking this learning now, working with Texmark as a partner, with HPE as a partner, to a lot of other petrochemical firms. And so we have set up, thankfully, to Texmark's partnership with HPE, we have planned a number of visits with other petrochemical firms here in the next several months. So,
thank you so much. I have a couple questions. I'm going to start out a little more technical, and then I'm going to move to a little bit more human, because I hear both elements in your conversations. Peter and Anna, you may have to chip in on this one. You talked about the wireless network and making a decision based primarily upon cost, but obviously in a critical environment, reliability is super important. What was the thinking beyond just the financials, that you had the infrastructure and the design correct, that you could move something like a plant to wireless, secure and safely? And what was some of the design elements that made you feel good about doing that?
So that's a great question. So keep in context that the Texmark campus plant's about 7 to 9 acres. And so one of the things that we wanted to do was initially do pervasive Wi-Fi, because we hadn't really narrowed down and prioritized all the use cases yet. So it was very important to establish a foundation so that no matter where we started, we could immediately start making progress. Because as we talked about, it's about time to value. The Wi-Fi, not only from a cost perspective, but also just a coverage perspective. Because if you run Ethernet, you could be running conduit all over the plant. That takes a long time to plan out. It's expensive. So there's a lot of challenges with Ethernet, right? You may have to use it in some cases, but Wi-Fi just had a lot of benefits, right, other than cost. And so that's allowed us to really impose it, because it's a Class 1 Div 2 environment. We put them in Class 1 Div 1 enclosures, and they're sitting about 6 stories high in the sky. So when you work in these things, you're doing it with a crane. You're not getting a ladder and climbing up and tweaking. So it's important that when you plan your wireless network, one of the things we always get asked is lessons learned. Have a more comprehensive in-depth plan before you build your wireless network, and you'll spend less time tuning the network after you get it built. Because once you start putting in these sensors, you start emitting data, depending on where they're located, you might have to tweak the antennas to get a better signal, to get better data. But really, there's a lot of reasons other than cost. It was time to value, it was flexibility, and it really did allow us to do a lot more with the fabric than if we ran Ethernet to everything.
Have you been able to maintain that pervasive uptime? Has there been any issues related to the wireless?
Well, there have been. So one of the things that, if you're familiar with Wi-Fi technology, you have directional aspects to it, right? Point-to-point connectivity. So Wi-Fi is outstanding for a lot of these use cases, but it's going to be supplemented likely with LTE. Because the thing about LTE spectrum is that when you start getting into the 300 to the 700 megahertz, 900 megahertz range, it penetrates metal a lot better than Wi-Fi. And so, is it going to be a combination of Wi-Fi? Is it a combination of LTE once you get to the plant and some Ethernet as well? So it actually can end up becoming kind of a multi-protocol environment, if you will. Because when you start getting into man down, let's say for instance, because health and safety is a top priority for Texmark, you need granularity. You need to know where a human being is or an asset, even on the asset planning piece, is less than a meter. In most Wi-Fi's that you're able to do about 3 meter granularity. So that's why, again, you're going to have to introduce in LTE and some other technologies, LPWAN maybe, to get you that granularity of less than a meter.
Yeah, I mean, great, a little, very technical, but I think it's valuable. So I think a lot of people hear, you went wireless, and you go, yeah, it's cost, but exactly what you said, what is downtime, what's the risk?
Daniel,
Yeah, go ahead, please.
Another benefit to going wireless is the maintenance cost of the wiring itself. And so if you have any sort of connectivity or troubleshooting that you need to do between the instrument and the DCS, wherever that may be, if it's 500 feet away or half a mile in a larger plant, then you're not having to trace this wire wherever it is in cable tray all throughout the plant. So you've got the workers wearing their safety harness, and like Peter mentioned, having to get the crane for access. So it's not just the installation itself requires some risk, and then the maintenance of the wire itself, and then having to troubleshoot and find where there might be some bad connection or bad wiring down the road.
Yeah, I think the traditional architect would probably look at doing both in many cases. So the fact that you sort of made the full commitment is the most interesting thing. Not that you're trying to make it wireless, it's just that you don't have that backup and that redundancy of wire, which oftentimes is part of the consideration. Anna, you talked about this video analytics. And one of the really hot topics now is this machine learning and artificial intelligence. But what it can do and what it's doing are different in many cases. I've been in presentations where they talk about, machine learning and recognizing animals and humans and not being able to separate the two of them because of coloring. And, so training is really important. And obviously, I think the group might be interested in the training of your video analytics to actually be able to deliver what you're saying. What's that going to take before it's going to work the way you guys are sort of envisioning?
Perfect. So there's a couple of options. So one is that there's actually really good libraries now that have been developed across very large image sets. So that if we're doing something as basic as object detection to say, is there something there, is there not something there? We can do that without a lot of site-specific training materials, which essentially means taking hundreds to thousands of photographs of what's happening on the railroad tracks, right? So part of the reason to say what's valuable around the railroad tracks is literally you want those to be clear, and if they're not clear, then you want to know is there something there. So we can really adopt the library so that we can very quickly have a solution that is added value. If we want to do much more sophisticated things, like say, we'd like to know.
Sorry.
What's the score? No. Go ahead, Anna. Thank you.
No worries at all.
Everyone needs a laugh.
So with if the use case requires it, we could take that to a level of doing facial detection or doing something to say, is it a coyote on the tracks versus, say, I don't know, some other type of animal. It's hard to imagine that there's a lot of value there. But, if you do need to know that, or if you do need to recognize individual people, then again, you can start with libraries and then do the training to really close the gap on that. We have talked a lot about doing a use case that is understanding if you start to have an overfill situation on their tanker cars. They already have very good safety controls around that, but if those were to fail, then the next level is to say if we could use the video analytics to make the operators aware that something else is going wrong. That is going to be a heavy lift from a training perspective, because all you have to do is say you're loading a clear liquid, and you're going to be doing that sometimes when it's raining or when it's dark. And so now you start talking about just the sheer number of images that you need to capture and tag and use as a training set. And those become pretty heavy compute, and then there's a lot of human time that's involved with just labeling those photos to say here's what works and here's what doesn't. The bigger challenge with that is you need something to go wrong that you can say this is wrong. So we're not going to ask Texmark to overfill the car so that we can get a lot of video of that, right? That's not acceptable. So trying to come up with the right way to really capture that use case, we're still working on that because we know that that's very, very valuable, but we need a way to do that is safe, right? And then gives us enough that we can actually have accuracy with the training.
Well, it's a great example of machine learning in the real world. Even the example of an individual, like there's a person who's an employee on the tracks, and is that employee there when they're supposed to be there? Because obviously many times internal problems in an organization are your own employees coming back to create a problem, right? Someone you recognize, they're trying to create a disruption. Do I know, are they there for the right reasons, the wrong reasons at the time? And is that your person or someone that just looks somewhat similar? So the training is evolving.
Yes.
But a lot of these really are proofs of concept we're building out. Like you said about the tanker and the fill, this is something until something happens, you're not going to 100% know
Right.
if the design is correct. Peter, you
I
wanted
just
to...
want to elaborate back on the original point you made about Wi-Fi. So one of the things these are pilots, we're trying to find a minimum viable solution here. So to your point about resiliency, Wi-Fi is a great way to validate a proof of concept that's going to provide the business value that you want. And if that's a use case that you wanted to keep and go forward with, you can go back and add the Ethernet resiliency. But right now, we're just trying to verify a minimally viable solution. Will it deliver the business value we think? With the software, everything integrated the way we think. And then, like you said, we can go back and add Ethernet later for certain connections if that's what's necessary. But keep that in mind. You want quick wins. Be able to go back to your stakeholders, not science projects, right? And you want to have something that's agile and that you want to tweak something and do something different. It's not very costly to have to go do that, and it's not going to take you a lot of time. So I just wanted to talk about that.
No, and that's great. And I wasn't challenging it. It's just a little different than the norm. So I think I'm going to throw this to Linda and Mitch in the middle here. I want to talk a little bit about the culture of change. You talked about the 50 people being the most important assets of an organization. New technology and all the research I've ever done on digital transformation is always met with resistance. You're asking people, an aging workforce, to work differently, to accept being analytics and them becoming numbers and data and having thousands of images of them captured. How is the organization handling you guys transforming from a very analog sort of factory? And then, Mitch, of course, maybe you can chime in too from the integration standpoint, how you guys helped to facilitate that on the consulting side. And Linda, maybe you take that.
Sure. I'm proud to say that we're handling it very well. I think it's about how we approached the project together with HPE. So the way that Peter described earlier, two of the main drivers for us even exploring an IoT solution was the need to upgrade our distributed control system, our DCS, and also to have a more robust mechanical integrity program. So when we reached out to HPE and said, how can you help us, how can technology help us with these two projects? They said, well, we have a great idea. Why don't you come out to our innovation lab at the HPE campus and take a look, and we'll tell you all about IoT. And they invited Doug and myself, and I said, well, that's great, I appreciate that. Can I bring some friends? And they said, sure. I said, well, can I bring 15 friends? And they said, sure. So we rented a party bus, and we all got matching golf shirts, you know. And we brought people from everywhere within the company, so ops and maintenance and lab and admin and engineering. And for a lot of these people, this was their first field trip, or I'm going to have a business meeting off-site. So they were a little awkward, and what are we going to go do, and what's this all about, kind of thing. So we're on the bus, and we're talking about barbecue and football, and or maybe a little nervous tension in the room, kind of thing. And then we get there, and then HP gives us a mini lecture on what IoT is, and kind of describes the edge and the theme, like Dr. Tom mentioned. But still, we're in this room going, okay, fine, that's great, this new internet thing, and how does that relate to us? I'm an operator, I'm a millwright, I'm a lab technician. But once we went into their IoT lab and saw the demos, we saw the smart city, and oh, that looks familiar, there's lights and streets, and we saw the medical application, the hospital bed, and okay, I get it, you want to track your things and your patients, and then we saw the car door with the window that goes up. Oh, that looks familiar too, we all have a car. But when we saw the sensored pump, the flow-served sensored pump, everyone in the group said, we have 130 of those in the plant. Tell me about that. And so we had someone in the group that pulled on the lever, took the pump out of alignment, and then saw that the augmented reality display said, okay, now this pump is going to fail in 6 hours, where before, when it was in perfect alignment, it was going to fail in 600 hours. And our millwright just lit up. It was, you know, like going to one of these kitchen and bath shows, you know, and you see this cool faucet, and you're like, I want that faucet in my bathroom. Well, he's like, I want that pump in my plant. I want that, whatever it is. And so that really
So it sounds to me like really what you did is you engaged
from
the team early, and you got them to buy in.
Absolutely.
Mitch, I don't want to cut you out, but we only got about 10 minutes, and I don't want to hijack all the questions. I wanted to make sure we had a chance for the room to participate. So somebody asked Mitch a question, because no, but in all seriousness, if we have any in the audience, or else I will
just say one thing. I think to Linda's point, the adoption of change, for somebody that's been changing, doing their work a certain way, really starts with the culture of the leadership of the company. I think because of Doug and Linda's leadership, and you see that with teamwork, they have a Friday lunch thing that, basically people are there to, help encourage one another. They're wanting to adopt change, which is interesting because you do see maybe some workers, some places, the culture doesn't really embrace change. But at Texmark, I think they've encouraged that. So George, the millwright, I was talking about George, looking at what does his day look like, how can he improve the way he looks at his job. So it changes his job and it makes it more effective. He likes to, learn new things. He likes to adopt. So I think they've embodied that culture.
From the beginning,
and I think
really the message.
Doug's quotes say everything about wanting people to be who they are.
Yes.
Right? You see that awesome sport coat? If I could pull that off, I would totally do it.
Sorry, I just thought I mentioned that.
No,
I think
thank
that's
you.
really important.
So what does the group want to ask these five folks?
Did your team have an idea of, we're missing this data, I really need this data, it will really help my job? Or was it after the field trip where they saw those examples where they really figured out, well, I didn't even think about this is data I need, or that this could be done, or that this could help? What was the B? Okay.
Truly, the visit to the lab, it's a whole new world. Wow, I hadn't thought of that before. Now, maybe if our engineer was sitting here next to me, he might say, oh, look, I knew it was there and I've been asking for this data and I want as much data as possible to fill up my spreadsheets and look at all these trends. But generally, we just hadn't thought of the possibilities of what the data could give us, bring us, data that maybe we hadn't even been looking at before, and definitely how data could add value, like I mentioned, to our contract manufacturing, to our customers. Wow, our customers, we think of our customers wanting to buy a truckload of chemicals, a barge load, a ship load, a rail car load. We hadn't thought of our customers wanting to buy our data. Wow. I'm going to put that on the list sheet.
On the price sheet.
That's right.
All right.
Data, accurate data.
Usable, valuable, interesting.
So we've done a couple projects. I've done a couple projects out in Port there in Houston. The biggest thing that we had to get around was Class 1 Div 1 and Class 1 Div 2. How did you guys deal with that with the wireless side? Because for us it was really expensive, large enclosures.
Eye-whopping enclosures, and that's why we chose the elevation that we did as well. Is, you know, you have a cone, right, a distribution cone, and so the higher you get up, the broader the cone is. Then you can supplement that with Bluetooth beacons and the like. And then we're also likely to introduce LTE into, once you get inside the piping, you know, more deeply. LTE is likely to play a role there as well. Again, Class 1 Div 1, you're looking at enclosures, and there's some devices out there that are intrinsically safe by design. So it's going to be a combination of that. And then you also have to consider the frequencies, the bands you're dealing with, and interference from other people using the same frequencies and bands. So there's a likelihood, we haven't crossed this bridge yet, of using private LTE. You know, you get spectrum that's dedicated. And
like CBRS? Sorry.
Oh, yeah. So to answer your question, there's a lot of considerations around the wireless communications piece. And again, our initial intent was to get a minimally viable solution in place that verifies it's really going to provide the value we think. And then once we do that, then we're going to start expanding the discussion on how to institutionalize it and make it productive and ready. But there's things that are already in discussion, and we're working with several partners to do that.
So you said it was 6 stories, about 6 stories high is where you mounted these.
IWAPs.
What type of client devices are you guys seeing? Because I know we did intrinsically safe tablets and I know some different sensors depending on their output power, you may have some issues. What are the client devices that you guys were deploying on the wireless side?
So we're using RealWear's under evaluation, GuardHat. Yeah, they all, right now GuardHat's going through their certifications now. And so that's a big factor is that one of the things we're talking about the connected worker use case is hands-free. That's a safety thing, it's also a productivity thing. And so when you look at the RealWear hard hat, and you look at the GuardHat hard hat, they have a lot of technology built into the hard hat itself. And again, both are intrinsically safe. The GuardHat one's coming out here very soon. So that's one of the devices. And the tablets and Panasonic is probably a leader in that space with the intrinsically safe devices. Because not a lot of people make them. They're ruggedized. Does that answer your question?
It does, thank you.
Yeah, and then of course there's the hands-free technology. GuardHat's looking at a shield versus the IBs, because if you think about, if you walk around and you've got something over this eye, how does that affect your equilibrium? Shield doesn't, right? Because you have both eyes looking at something which is normal. Because you normally look through 2 eyes, not one, right?
Sounds like a great way to build some augmented reality
Yeah,
right into the
exactly.
visor at some point. All right, we have time for one more question. Okay. So, Gene, you got it.
So you really went far way down the path of answering my question about were there new screens that people had to use and all that. You're saying there were some ergonomic things that fit into their environment, but were there also new screens that had to be included in the testing and the training?
So those are being evaluated now. I would love to say we're far down the road in that, we're not. And that's an area that's evolving very rapidly, by the way. And so we're trying to go with a minimally viable product. So the first priority is connectivity. We want to have audio, video, and be able to reach people where they're at in the plant. That's the first priority. And then once we can get that done and start getting people used to that kind of bi-directional communication, then we would expand use case eventually to have the wearable technologies and to start doing some of the proximity granularity pieces, which are more complex and more expensive to do. But right now we're focusing on simplicity.
And then if you want to would that then feed back into your existing safety system?
Absolutely. That's absolutely true. Because GuardHat actually has a platform that comes with they're not just the device, they actually have a whole platform. And that it's extremely rich. And I could spend a long time talking about that, but it will. And what you'll find is those use cases are talked about individually, they're going to coalesce. They're all going to come together because if you think about the interoperability, all that data is needed in different contexts for these different roles, not just this piece of data or that piece of data, it's an and, not an or. So you'll see that again coming together later.
What a very informative conversation. I know everybody has places to go. Do you guys mind giving a little round of applause to our